This conference will now be recorded.
Okay. Okay. So, guys, in the last session, we discussed the basic difference between XML and XSD. XML contains the data in the form of elements. XSD contains the definition of data. Okay. The basic difference we identified in the last session. So now, why we need an XSD? What is the reason why we discussed about XSD? What is the background of it? Why we really needs an XSD? For that, to prepare well-formed and valid XML. Okay, I mean, or in another way, let me keep it in another way. We want to prepare a proper XML. Proper XML means it should be well-formed and valid. What do you mean by well-formed? If the XML follows syntax rules, it is well-formed. If the XML follows definition, then it is valid XML. Okay, at any time, if you want to prepare a valid XML, you must have definition along with the requirement. Okay, you have some requirement and you must have definition. Then only you can prepare valid XML. This is the steps you need to follow to prepare the valid XML. If you don't follow the definition, XML becomes well formed but not valid. Okay, this is what we discussed in the previous session. Now let me I mean, as of now we saw few examples, right? Let me give you one more example. Suppose the requirement student name, I think we discussed about an example, right, in the previous session. So what we discussed, we have an example, student name is Ravi. Okay, this is the requirement. If I want valid XML, for that I should need a definition. So what is the definition here? Let's say definition is create simple element, name it as s underscore name. Okay, and use string data type. So now if I want to create the XML by following the definition, can someone tell me how to prepare the XML?
Yes, underscore name element.
With you should tell the full statement within open tag. Within open tag s underscore
name close tag
then the data is Ravi close tag s underscore name. Okay, so if you prepare this way, because this XML is following the definition, so it is valid XML. Okay, so but I wrote the definition in a theoretical format, which is not programmatical format. This may not work in a program. Okay, we should learn a programmatical format of definition, that is nothing but we call it as XSD. Correct? As per the discussion, definition is nothing but XSD. XML, the full form, XML schema definition. Okay, XML schema definition. Now we need to learn how to write an XSD in a programmatical format. Writing an XSD means what? Defining a simple element, defining a complex element, defining an attribute. If we are able to do this, that means we are good to write an XSD. Okay, right. Let me introduce the programmatical format, how to define a simple element, how to define a complex element, and how to define an attribute. Let me start with define a simple element. Okay, define a simple element. Is all good? Everybody is able to follow, or any questions? Anyone have any issues?
My end, no, nothing from my end, sir.
Nothing from your end. Okay. Give me a second. Looks like someone has an issue. Sampath is reporting an issue. Okay. Right. So how to define, let's see one by one, how to define a simple element and complex element. Okay. And then attribute. Let me start with the simple element. It's very simple, guys. You need to by heart the syntax. Going forward, we'll see more customizations, how we can do. But first, to kickstart, you just by heart the syntax. Okay. The syntax to define an element. Okay. Element name is equal to something. I need to fill the blank. Type is equal to something. Okay. And I need to fill the blank and close the tag. See this, the syntax. It is predefined keyword. It filled with predefined keywords. Okay. There are 3 keywords in this statement. Element, name, type. So there are 3 keywords. Okay, and these 3 keywords are fixed and predefined keywords. You must not modify this. Okay, you must use as is. Okay, now suppose let's take this example only. So I wrote a theoretical format, right? Here I wrote a theoretical format. So if I write the same theory in XSD format by following the syntax, it looks like this. Element name is equal to, see this, guys, in this blank, okay, I want to write user defined keyword. In this blank, it is user defined keyword. So as per our definition, what is the element name we are expecting? As per our definition,
Yes, name, sir.
Yes.
S name. Of course, S underscore name is a user defined keyword in this definition. Agree? But we all agreed to use this keyword. Okay, so whatever the element name you want to use in XML, whatever the element name we decided to use in XML, that element name we have to define here. We thought of using this keyword S underscore name. Okay, type is equal to what type of data it is, what type of data type we are expecting?
String, sir.
String data type. So string. Okay, if you see this example, this is the syntax to define a simple element. Syntax to define a simple element. This guy don't have any data. XSD don't contains data. XSD contains definition of data. Okay, we are defining an element here. Defining an element means we should tell what is the name we have to follow, what is the data type we have to follow. This is what the definition contains. So by following this definition, if somebody prepares an XML, let's say someone prepared an XML like this, okay, by following the definition. You tell me, I'm giving some examples here, okay? Okay. Can you unmute your machine? Can you unmute your mic and tell me XML-A, is it well formed or not?
Well formed.
Yes, sir.
It is well formed.
Yes,
Okay.
sir.
Is it valid or not?
Yes, sir.
Yes, sir.
Come
Valid.
on, quick, guys. Don't delay.
Yes, sir. Valid.
It is valid. It is valid. Why? Why it is valid?
Because it has a definition.
No,
Definition.
Yes.
no. Statement
Follow.
wrong. Correct your statement.
Following.
It is following definition. It's
Yes.
not that it has definition. It is following definition. Correct your statement. Okay. So how about the second example? S name. Is it well formed or not?
Yes, sir. It's well formed.
It is well formed, no doubt in that. But is it valid or not?
No, sir, it's not following the definition. It's not.
It is not following the definition, so it is not valid. How about the example C? Is it well formed or not?
Yes, sir, it is well formed.
No.
It is well formed.
Sir,
Is it valid or not?
It is
No.
not valid, sir, because it's not
It
following
is
the
not
definition.
valid because it is not at all following the definition. It is not at all following the definition. Okay. So hope you understand, right? How to write definition, how to write XML by following the definition. Okay. And we saw the syntax, how to write a simple element, how to write definition of simple element. Okay. Now let's see how to write definition of complex element. Okay. It is also very simple syntax. You just need to remember the syntax, guys. Definition of complex element, right? So let me take an example again. Student ID is 101. Student ID is 101. His name is Raj. So in this example, we have more than one data. That means we need to create more than one element in XML. Okay. So by looking into this example, we have two data parts. One is student ID, another is student name. Two data parts. That means we are expecting two elements. That means we are expecting definition of two elements. Okay. And when we have more than one data field, we have to maintain a complex element as well. So that means in this example, we need to define one complex element along with two simple elements. Okay, so let's write the definition. Let's write the definition for this. Okay, what I will say, create, give me a second, guys. Okay, sorry guys, I got some call. Okay, so create two simple elements. Create two simple elements. Name them as S name. Okay, SID and S name. Okay, something like this. SID, S name, and follow data types as integer for SID. Okay, integer, and string for S name. String for S name. So this is the definition I want to follow, but I created it in a theoretical manner, which is not programmatical. So how we can write this in a programmatical way, we'll see now. Okay, first we'll see syntax, how to write a definition for complex element. So let's see the syntax. Element name is equal to something. I need to fill in this blank. Under this, complex type. Under this, sequence. Under this, here you need to define your simple elements, or I can say sub elements, whatever sub element you want to define. Define sub element. Okay, guys, when I said sub element, it may be simple element or complex element. I will explain what I mean. Okay, it may be simple element or a complex element. And then close sequence, close complex type, close complex type. Observe here, there are few small letters and few capital letters. You should maintain the same type. Okay, wherever I am using lowercase, wherever I am using uppercase, you have to maintain the same thing. See this in this syntax. Okay, these are all the predefined keywords. Element is a predefined keyword. Name is a predefined keyword. Complex type, predefined keyword. Sequence, predefined keyword. Okay, so this is the standard syntax you have to follow when you are defining a complex element. And here you need to define your sub elements. When I said sub element, it can be a simple element or a complex element. I will show you the example. Okay, let's go back to our example. So we have a requirement and we have a theoretical definition, but we want the definition in XSD format. And to prepare the definition in XSD format, we need syntax. Okay, as per this example, we need total 3 elements, 2 simple elements and 1 complex element. Okay, so what we wrote here: create 2 simple elements, name them as SIDS name, follow data types as integer and string. What else we need? We need 1 more complex element. Okay, group about 2 elements, with a complex element. Name it as stu info. So now total 3 elements we want to define. Total 3 elements. Okay, let's follow the syntax. So as per syntax, use the same syntax. Okay, element name is equal to, what is the complex element name we want to use? What we decided to use as complex element? Student info. So you need to write the standard syntax. So what is the next one? This line completed, right? This line completed. What is the next line?
Complex type.
Complex type. Next, sequence. And then we need to define sub-elements. We need to define sub-elements. When I said sub-element, it can be a simple element or a complex element. So, but in our example, we want 2 simple elements. In our example, we want to define 2 simple elements. Okay, and you already know the syntax for simple element, right? You already have the information how to define a simple element syntax. Okay, yes, now use the simple element syntax here. We want 2 simple elements. Element name is equal to s. What is that? What is the keyword we thought of using? SID, s name. SID type is equal to what? Group data types as integer and string. The first one is integer, second one is string. Okay, this is integer, and define the second sub element, which is a simple element definition. S name type is equal to string. Okay, now we need to close sequence, complex type, and then element. So you must close the tags. Whatever you opened, you must close the tags. So now this is an XSD for our requirement. This is our requirement, right? Student ID is 101. His name is Raj. For this data, what we thought is we want to create an XSD. XSD contains definition of data. XSD don't contains the data. See here, we don't have data. It contains definition of data. Now I need to prepare the XML by following the definition to make it a valid XML. Okay, as per definition, this is definition. Okay, as per definition, what is the name of the complex element? Come on, guys. What is the name of the complex element? Student info. Sorry. So the name of the complex element is student info as per definition. Student info. Student info contains two sub-elements. What are they?
Student ID.
SID,
SID.
SID, and then S name. S name. Okay, close student info. Close student info and fill the data. What is the data? 101 Raj. Okay, student ID is 101. Student name is Raj. Okay, see guys, this is what programmatical format. This is the XSD. This is the XSD. See, nowhere we use this theoretical format. In our programming, when we are writing a web service, nowhere we use this program theory part. Okay, we will have an XSD. By following the XSD, we will prepare an XML. Clear? Any questions? So this is called valid XML. Okay, now I will give you one more example. Suppose I want to clarify this point. Defining sub-element, right? In this syntax, in the syntax of complex element, here I said define sub-element. When I said sub-element, it is a simple elements or a complex element. Let me give you one example for that. What I mean by simple element and complex element. Suppose I will use the same example. I have an XSD. Okay. So in this XSD, I want to define third element here. Third element name is equal to, I will say address. Okay, element name is equal to address. I want to define address as a complex element. Okay, address as a complex element sequence which contains simple elements city, okay, state. Element name is equal to state. Type is equal to string, the data type. And I want to close sequence, close complex type. You must follow the syntax. It may be sub-element or it may be parent element or the root element. You must follow the syntax. So in this example, total how many elements I defined? 1, student info, SID, SNAME, address, city, state. So total how many elements I defined in this XSD? 6 elements. 6 elements. STU info, SID, SNAME, address, city, and state. Total 6 elements I defined in this example. So if I want to write XML for this, just for the convenience, I'm writing in this document. Okay, to keep the things in one screen, I'm writing here. I'm writing the XML in the other document. Okay, there is no other reason. So what I'm doing, I want to prepare an XML by following this XSD. Okay, so what is the topmost element?
Info.
U info, the complex element. STU info is the complex element. Under that, inside student info, sub elements. SID, SID, something. I'm just giving some random data, guys. We are really not worrying about accuracy of the data. Okay. S name, student name. No, don't say student name. You should say S name. Because how it was defined in the XSD, the same keyword we have to follow. S name. So in the XSD, N is capital. In the XSD, N is capital. So you should use N capital in XML. Okay. And then address. Address is again a complex element. And under address, city. Okay, under address city and state. So don't worry about the data. I'm just taking some random
Close
example of data.
address.
Close address. Close address. Are we good, everyone? See, now compare how the XSD looks like and how the XML looks like. Let me change the language here. Just to give you the good view, I just changed the format of the document. It's not mandatory to change the format of the document. Okay, fine. If you see, you have XSD, which is defining 6 elements. You have XML, which is following XSD to make it as a valid XML. Any question till now? Any question? No?
No, sir.
No? Okay. So this is how we need to write one basic XSD. I mean, there are few other things we need to learn while writing an XSD. But anyway, this is the minimum basic required to start, to kick off how to write an XSD and XML. So guys, do you feel any difficulty to write XSD and XML? Are you comfortable, or any questions you have?
Comfortable.
Comfortable? Okay. So guys, I want to tell you one small update here. Not update, I mean one small info. See, when we are writing something, like this, suppose STUID 101 STUID. Okay. So this is called a simple element. Simple element. The name of the element is
Sir, your voice was breaking.
ఇంకా మాట్లాడలేదు కాజాబాయ్.
ఇక్కడ స్పీకర్ రన్ అవుతుంది. నువ్వు మాట్లాడేటప్పుడు ఇక్కడ చూసావా గ్రీన్ లో బ్లింక్ అవుతూ ఉంటుంది.
ఇక్కడ గ్రీన్ లో అంటే అక్కడ సార్ వాయిస్ బ్రేక్ అయినట్టుంది బాయ్.
ఓకే.
Kaja bhai.
విక్రమ్ భాయ్.
Kaja bhai.
హలో విక్రమ్ భాయ్ చెప్పు.
Sir voice వినపడుతుందా?
Is I'm audible?
Yes,
I'm
sir.
audible?
Now audible.
Oh, sorry guys, I mean some power connection issue. I lost the power. Okay, so if you see, I'm talking about something called empty element. Okay, empty element. So what I mean by empty element? Suppose in this example, if you take this example, okay, so this element contains the data. Student ID is the element name and 101 is the data. Okay, suppose there is no data, the same element we will write like this, STUID, and there must be a closed tag. This is how we write a empty element. Okay, so there is an alternative format for this empty element. Alternative format, we can say STUID self close. Self close. When there is no data between open tag and close tag, we can say it is an empty element. Empty element you can write open tag and close tag separately, or you can also write it like self closed tag. This is called self closed tag or empty element. Any question? Any question about empty element?
No, sir.
No question. You are clear, right? So suppose if you say in this example, suppose I have no data for SID. So this is the empty element. This is the empty element. I can also write the same empty element in a different way, like this: self-closed element, SID, self-closed, and it has no data. Self-closed means it has no data. It's an empty tag. Okay. So we will see in the practice. We will see this empty element so many times. Okay. And come to the XSD syntax. If you see XSD syntax, this is an self-closed tag. Observe here. This is a self-closed tag. Understand? Clear, right? This is a self-closed tag. So we can also write it in another way. As per our discussion, you can maintain the empty tag. I mean, you can maintain the close tag as well. See, this is the syntax. This is open tag from here to here. This is open tag, and this is close tag. Close tag. Okay, it is your choice. You want to follow what kind of syntax? You want to follow syntax of line number 60, or you want to follow syntax of line number 61? It is your choice. Any questions? Any questions? So you understand this format, right? This is self-closed. This is self-closed. If you elaborate it, you have to write separate open tag and close tags. Okay. This syntax you can use in XSD. This syntax you can use in XML as well. I mean the empty element syntax. Any questions? Any questions? No? Okay. So okay, if no questions, guys, now you all need to do some practice. Okay, so what we need to do, I will let you know. I will stop the recording here. We'll do some practice. Okay, let me stop the recording.